What's up, everybody? Today we are working on making a B-tree visualizer. Context is, yesterday we wanted to look at our trees in order to assist with some like really expensive calculation of things in our code map based off of distance. We have a bunch of nodes on a graph, and they're doing like some sort of like n squared interaction between them. And so we're like, well, we can kind of limit interactions between things if we kind of say like, okay, I'm looking at this guy, only look in this radius. Don't look at like the whole world. Don't like calculate some number between you and every other node in the graph, right? That's slow. Boo. And so we wanted to look at our trees, and we were like, our trees. That sounds like complicated. Our trees are basically like they kind of have these rules of like you kind of make a tree structure where you have like boxes and boxes and boxes. And I was like, oh, I haven't like written a tree for a long time. Let's do a little warm up. Let's make a bee tree. Bee trees are kind of cool. I've had some ideas about like bee trees before. The idea of a bee tree is like you have some sort of like sorted data, and the data actually comes in like clumps, right? And the idea here is that you should be able to gain some sort of like nice balance between like uh not missing your cache because you load in like 64K of stuff at a time, or 64K, whatever like one cache line is, amount of stuff at a time. You want to make sure that like you're leveraging all that stuff, so you go in sequential order so that like the memory management unit can like predict what you're gonna get. If you like have like some sort of linear scan, right, memory behaves better. But when you have like trees, you have better insertion, you have better deletion. You don't have to like shift all of the data every time you do anything, right? So a B tree is kind of like a way to have some sort of like nice balance between those. And I've kind of wanted to try implementing one for a while, and I was like, this seems like a good warm up, a good 1 hour warm up task so that we can get familiar with writing trees. And I was wrong. It was not a 1 hour warm up task. And so yesterday we spent a lot of time writing some B trees. We are not done yet, but we have something, right? So we have like we insert some stuff in here, and if we look at the storage, we see like this is like the root node. And the way this B tree works is like the number 3, it goes like, okay, so there's stuff to the left of 3. 1, 2 is to the left of 3. Then we have 4, 5 to the left of 6. 7, 8, 9, 10 to the left of 11, 12, 13 to the left of 14, 15, 16, 17 to the right of 14. That's kind of like the way the B tree is working. But trying to show it this way kind of sucks. And so I kind of figure if we're going to do another day of this, it would be nice to be able to like look at it in some way that is like pleasant for me and for stream. And so that's the plan today. I just want to write like a visualizer for this thing. So kind of what I'm imagining is something that resembles this picture here. So I'm kind of imagining that like we start with our root node that has some sort of like number of elements. And in here we show like as things get added, we show like the first element go in here, the second element go in here, right? 2, 3, 4. And then I want to show like, okay, so then we add like a fifth element. I want to show like maybe down here somewhere. Maybe what's like a good spot for this? Probably like up to the right or something. We put in the 5. The 5 doesn't fit. Right, so put the 5 out here, and then like show that this is going to get split into 1, 2, 3, 4, and then once that's done, we can like kind of put the 5 back in here, and we should be able to show like how that like insertion propagates up the tree. So we need to do something. We want to do something. I want to do something like semi-interactive, right? I want to be able to basically step each chunk as it happens, right? So I kind of want to see like I spam the next button, and when I spam the next button, I want to see like the 1, 2 show up down here, and then hit next again and show like the 3, 4 up here, and then hit next again and then show this replace the 5, right? That's kind of what I want to see. So I want something interactive and something that shows this, and then probably something that also shows like the storage format. So like maybe how these guys are laid out in memory, right? So maybe like I don't know how I would show this, but like somehow say that like this is here, this is here, this is here, and then maybe we can show some sort of like memory utilization or something like that. I don't really know. We'll see. So plan of action is get any visualizer up and running. We need like somewhere to like render stuff and like, have buttons. Display the root node, display all nodes, and then do like the interactive part. And let's just jump in and see what happens. So there are a few options for this. Two-step said GraphViz, that's an option for sure. I was thinking of also like SVG output is an option, as well as like maybe like a web page with an HTML canvas. I feel like my gut says HTML canvas is like the way to go here. It just kind of feels like um as we as we get to like the interactive part, as I start slamming like the next button, I feel like getting state updates in terms of like just like some JSON blob. I don't know, that has like some stuff in it. I don't know what will be in it. I feel like just re-rendering to the canvas makes more sense. I feel like it will be easier to do that than to hook up like write like an SVG renderer today. That's just kind of my gut feel. So let's write some way to test our B tree that has like some sort of like, I guess we need like what, an HTTP server and like a canvas to render nodes into. That's kind of what I'm thinking right now. That's what I'm thinking. Which means that here, I guess we just go. Is there like HTTP in this thing? HTTP server? That seems reasonable. And we have to initialize with some sort of connection. So, I guess, what is in this thing? Net server connection. Where do these things come from? These things come from accept on a TCP server. Sure. So we go like, make me a TCP server. How do I make a TCP server? I think it comes from like an address. I think you do something like this. Parse IP. Can we do like 0000 port 80? Sure. And then we go like addy.listen. Yeah. That sounds right to me. We're gonna set reuse port is equal to true because I feel like we often crash these things and then they don't, the port stays in use for too long. And then I guess we say what we like server accept some connection. While true, we wait for a client. We will only support one client at a time right now because that's easier. And then they're saying now you can initialize an HTTP server with a connection. And we need some sort of read buff. So let's give him some data. Fuck it, you know? Okay. Now what happens here? What happens here? This guy gives us an HTTP server. And presumably this like allows us to do stuff, right? Surely. So I guess we like get some data. And this is going to give us a request, which has a head, which has a method, a target. Cool. Okay. For now, can we just respond with like no matter what with hello world? That sounds kind of sick for us. So this guy says receive head, and then surely there's some way to like send data back. How come my control D is not going down by more than one line at a time? That was weird. Vim thought that the buffer was like 3 pixels tall or something. Okay, so there's receive head. Is there some sort of like write or send? Respond? Okay. Respond is on the request. Okay, is this the request? Yes, okay. So this is a rec. Var request, rec respond. And can we just be like, hello world? And probably like I don't give a fuck options. I wonder if that's allowed or if we have to respond with some amount of stuff. It looks like he just says go ahead. You can just say you don't give a fuck and we'll figure it out from there. Okay. And then will this build or will he get mad that the following stuff can't run? var server. I guess here we need to do something like this. We need to service the connection until it drops. So probably here we go like catch break on both of these guys. And then probably we need to do like connection drop. Probably. Something like this. Okay. So he's mad because probably port 80 is not allowed. I think that's reserved. Can we do 8080? Hell yeah. So curl localhost 8080. Hello world. Let's go, baby. HTTP server up and running. Okay. So now we have to, I guess, do something sane here. So I guess what? We'll have some HTML and some JavaScript that we want to serve from here, I guess. Probably. Don't forget to use reuse address. I think that reuse address is fine. I think it's only the port that becomes a problem. That's my memory of this thing. Okay. So I guess we're going to be like what a coincidence. I recently started working on B-tree balancing and page garbage collection. Let's go. Okay. So I guess we want to look at like rec head target. Yeah, here we go. And we have like URLs that we're going to want to service, right? So maybe we go target is like we might have index. We might have kind of an empty page. And we might have index.js. Okay. And we are going to want to respond to each of those things in some reasonable fashion. So here we try to like, I guess there's also going to be eventually like data, right? Eventually. But for now, we can just start with serving. That's fine. So can we like parse this thing as a target? And then we go like switch on the target. And if it is this or this, we serve our index. So here we go. Oh, these need to have dots in front of them, right? Like this. Yep. Serve file of, I don't know, res index HTML, I guess, for now. With the request, I guess. And then we have index.js. Okay. And then we have data, which doesn't exist yet. So I guess if we get data, we'll just respond hello world. But on these guys, we need to serve the file. So serve file takes a path as well as a request. Like this. This is good enough. We do like open the file. We got to be careful about this. I guess it doesn't fucking matter. There's like security concerns with just doing this, but fuck it. You know, we can do what we want. F dot read to end alloc. I guess that means we need some sort of allocator here. We allocate a buffer and we read it to the end and we say, please don't read more than a meg. We need to probably close the file and free the data. And then it's just like rec respond with data and some options in here. So I don't know. I guess let's just send it and see what happens. I think that we have to set like the header type so that it knows that it's HTML. But let's just start there. So here we'll do, you know, some HTML. And then what is it? It's like doc type HTML or something? How do people make websites? I forget this every fucking time. Doc type HTML. Yeah, that's right. Head, body. And we go like, hello world. Let's just start there. We'll start there. So we run this thing, and then he's mad because we need to say that this target might not parse. All right. Serve file, we forgot to pass in the allocator. And we forgot to write try. And then he's pissed because open file needs some arguments. Fine. You're gonna be like that. He's mad because I didn't write try here. And I didn't write try here. Okay, so now we go to localhost 8080, was it? Yep, and we see hello world. That's good for us. Huge for us, actually. And if we go into index.js and we say, I don't know, window on load is init, then we say async function init. How do you do this language? Function console log hi mom. And then in our index.html, we say script source equal to index.js. Is it like, it's like this, I think? Yeah, that sounds right. Refresh and look at the console. Nothing. Network. Index.js. We served the wrong file. We need to serve the JavaScript if we ask for the JavaScript, if you think about it. If you think about it. Okay. So we look again. We look at the console. Hi, mom. We are so ready to go. HTTP server, ready to go. So this guy, he needs a canvas. Probably with some like initial width and height. I don't know if it's like this. I think it is. Okay, so then in our JavaScript, we would probably go like document get element by ID canvas. And we say that this is a canvas, and then you have to like get the context out of here. It would be sick to have like autocomplete in here. Can we fix our environment? Use one where we have all the tools we need. This one looks like the one. Let's go into, oh fuck. Physics sim. This guy had a good shell to yoinkies that has all of our language servers and shit. Give him a sec. Oh no, he's running JS. Yeah, not again. No. Not again. All right. So we run this guy, and then is this environment good? If we go into index.js now, can we go like, yeah, nice. It's like type is HTML canvas element, nice. And then we can go like get, is it context? And then here we do like 2D. And then here we should be able to like fill rect from 0, 0 to canvas width, canvas height. And I think we have to set the fill style here to like red. I think that's how this works. if I remember correctly. Oh, we're so fucking ready to go, baby. Let's go. Okay. So now can we do something like I guess we need to query the server for some data. Let's actually, I guess let's pretend that we're gonna render a cell here, right? So like we were saying before, we're probably gonna want to draw something that has like numbers in box, right, in some sort of like tree structure, and we probably wanted to take inspiration from this guy because I felt like that was good. God damn it. Go, go, go. There we go. I liked this picture. So something like this. So maybe we can try rendering a number in a box. Let's just render a number in a box. So, I don't know. Let's put a number and like a XY pixel offset? Maybe? Seems maybe fine. We probably want to define like the width of a cell somewhere. I don't really know how this shit works, to be honest. I assume that we go like, I want tabs or spaces, and I want them to be 4 wide. There we go. Okay. I guess let's just see if we can like draw some letters somewhere. There's a way to like fill text. Here we go. So like if we just set this at like 50-50, what does this look like? I think probably we need to change the fill style to black or something. Okay, that's way too small. Can we set like the font size? Canvas font size HTML. It's too small. Really? Really? This is how you do it? I don't want to pick the font. Oh, you can just bump 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 bump. Yeah, it does seem like you have to pick a font. That's annoying. I don't really give a fuck, dude. I don't give a fuck. So they're saying like 30 pix Arial. Okay, that's fine. I guess in reality, we'll probably zoom in. Maybe like the default text size is fine, to be honest. If we just, yeah, it's not 30. Okay, good enough. Good enough. So if we want to render a cell, I guess we render like a box. So let's say that this is like the center position, maybe the center XY. So we'll probably do something like x minus cell width over 2, y minus cell height over 2, and then I guess we'll do half cell width here. So I don't have to fucking keep running the same shit. There. So now we can do minus half cell width like this. Boom. Boom. And then we use the full width and the full height here. And we pick a color for this thing. So cell color. I don't know. 040404. Yeah, 040404. Fuck it. Okay. So let's do like render cell. This guy needs the context as well, I guess. 50-50. He doesn't like that for some reason. Why? if I fill it with black, why is this not doing what I want? Why is this not doing what I want? If I do this down here, does it do what I want? No? Am I stupid? Oh. Maybe we should look at our errors. X is not defined. Okay, so string literal contains unexpected line break. What the fuck? Where? Oh. Okay, so that's like supposedly working, but I don't see anything working. If we crank these up to like, you only pass 3 params. Yeah, that's true. That's a pretty good point. There we go. Pretty good point. Pretty good point. Thank you. It's crazy that I didn't see any like obvious errors from that. That's insane, but I guess it is what it is. Okay, so this was cell color. I just want to see like, okay, there we go. Sure, gray's fine for now. Maybe even like darker gray. Too dark. Okay, good enough. Good enough. Okay, then actually, I guess if we're doing dark text, we want this to be relatively bright. So we probably want to do something more like this. And then we can put the text inside. So can we just do this? Like x minus half cell width, x minus half, or y minus half cell height? Well, that just kind of... okay, so this looks like it's doing the baseline for y. Okay, and then arguably we have to center this stuff. But for now, can we like... I guess we can check. HTML canvas center text. Text align. Oh, 6. So you can just do text align center. Here he doesn't know what CTX is, so I guess we have to tell it. How do you do this? Function parameter. So we have like param HTML canvas rendering context 2D like this. Then it was like text align equals center. Okay, so now we just put this at XY. Close. That's only like right left. Is there a way to center vertically? HTML canvas center vertically. Center text vertically. Text baseline. All right. Beautiful. Beautiful. There's our little 10 in a box. Okay. Cool. Cool. So I would consider this done, and let's try to render out the root node now. Let's try to render out the root node, which means that our server needs some way to retrieve that shit. So I guess we have to respond with something sane here. So I guess let's initialize our B tree before starting the server, I guess. That makes sense. And then we can just start looking at that thing. So we can go like, B tree, get by node ID, root node. And what the fuck is this thing? This thing has elements and num elements. Sure. I guess here we're going to do some sort of like rec respond Probably something like this. You can't, I guess you need the content length. Oh, you don't need to know it up front. That's hype. So it looks like I can just use like a send buffer here. And it looks like we get like response handle like this. And then I assume that this response handle has like a stream in it. Hell yeah. Do I have like a writer in here? I do. Yeah, we do. Okay. So we can get like a writer out of this thing. This seems like a lot of work. Actually, let's just do it the dumber way. We'll do it the dumber way. So we'll just actually say serialize node. And we'll free it. And then we'll send the response here. And then maybe we have to set the content type to JSON. Maybe he'll figure it out. We'll see. Serialize node. So he takes in a node like this. I guess unfortunately we need. I guess this is just going to be an any type because I don't want to deal with this right now because it's kind of like typed according to how many elements are in it. But we can figure this out. For node num elements. I guess we do like we need to serialize this and put it somewhere. Okay. So something like this, and then we probably do something like this, and we make some sort of like JSON writer, probably. Write stream, I guess, around something. Probably something like this and like this. Probably want to say white space equals indent 2 so we can read it. Then here we do like JSON writer begin array, I guess. And here we do end array. Okay. Then for each element in this thing, JSON writer write elem question mark seems kind of fine. Okay. I guess we'll do it like this. Okay. Sure. That's like a maybe. Begin array, he's mad because this thing probably has to be variable. And this thing needs to have failure supported because things can go wrong. True, num elems. This is an index into node elems I. Okay. And we forgot reg try here. Okay. So now if we go to data here, we sure do get the root node 3, 6, 11, 14. That's big for us. And I guess we show that in some way. Probably. Okay, if we do here, if we go like, how do you do this? If you like, it's like fetch. Yeah. We fetch data. We go like, you want like JSON? Here we go, yeah. Data rec. We get the JSON out of it. Can we just console log the data real quick? Like, does this work? Network error when attempting to fetch resource. Why? Why? It was this, right? Oh, now he's mad. What happened? Yeah, this is fine. You gotta wait, JSON? Oh, yeah, that's a good point. Good point. Good point. Although he still doesn't seem too happy. If we do body here, does it behave differently? Body's not a function. Fetch JavaScript. I don't remember. I don't remember. What if I don't want JSON? Like, is it because like the content type is wrong? Is what I'm trying to figure out. So how do I just like pull the body out? Await fetch. Fetch body JavaScript. I just want like a quick answer. I guess this is what like the idiot is for. Fetch JavaScript body, not JSON. Text. Yeah, okay. So he does get the text if I do it this way. If I do JSON here, he gets stuck forever, probably because the content type is wrong. So I think that I need to set the content type header here. And we go like, what is this thing? HTTP header, which is a name and a value. And it's like, content type JSON. Oh, well, you know what? Let's continue on. Content type JSON. Let's just see. Oh, man. He must be. I treat him like such shit. Really? Const. Expected this, found extra headers, expecting a list of const HTTP headers. Is it like this? Is that why? Yeah, it is. There we go. Okay, so now if we do it with JSON, he's actually still not doing it, huh? It's surprising. Dude, am I stupid? JSON. Oh wait, JSON does not return data, text does. It's not helpful. Dude, I feel like I'm like losing my mind. Can we check here? Maybe we are fucking up in some way. Sto debug print sending response. And maybe we'll even write try here for a better logging. And even here, we can be like, here's the response. Because I feel like I'm losing my mind. Refresh. Oh, there we go. I don't know why it's different there. What the fuck? The fuck? Am I stupid? So... Still using text? Am I? I fetch, and then I call JSON, and then I load. And it seems like we don't finish sending here somehow? Is it because here I need to like rec does respond not finish? Like, it seems like respond should be good enough. I mean, it was good enough to serve files, so why would it not be good enough to serve our JSON? Content length? But I feel like it automatically figures it out here. Yeah, here he sends it correctly. It's like there's something about like having to go twice that I'm missing. Right, so here the server is like not finished sending, but if I refresh here, then it's when I refresh on the other side that he's like, okay, we'll send the response. Which is weird. Got request for this. Tag name here. Okay, so here he doesn't even think that he's getting this. Oh, maybe it's because the favicon response fails. So maybe we have to actually go like rec respond status is equal to not found. It's probably something like that. Probably something like that. There we go. Yeah, so it's because he was waiting on the favicon. Waiting on the favicon. Okay, cool. So now we have our root array. Hell yeah, dude. So now we should be able to go like, I don't know, for data, for elem of data, for let elem of data, elem here. And we have to, you know, track our X position and stuff. So, oopsie, what the fuck did I just do there? Let X is equal to 50, and then we go probably have like cell padding. And we probably go here and we're like, go to X, and then we say X plus equals cell width plus cell padding. Boom. Boom! Let's fucking go, baby. That is our fucking root node. That's our root node. All right. Probably we want to maybe render like a background behind that thing, but in reality, that's good enough for now. Good enough for now. Okay. So now what? Display all nodes is the next thing. Okay, so the question is how the fuck do we do that? So we need to like respond with some JSON blob that represents the structure of the tree. So I think probably what's easiest in terms of like not doing too much garbage in JSON is we can go like, maybe we go like for let row of data, for let like cell of row, for let elem of cell. Right? That kind of seems reasonable to me, like a triple nested array here. I think I like that. And so we just go row by row and render each cell. That seems reasonable. Which actually is pretty easy in terms of implementation because our data layout in the B tree is already a lot like this. The data layout in the B tree is just like, it's like root, then like child 1, child 2, child 3, then child one's first child one's second child one's third child, then child two's first child two's second child two's third child, right? So this already is like really well laid out for this stuff. All we have to do is figure out which nodes are like within each layer, right? We just need to find these points, which we have like a thing for somewhere. Depth start iterator. Hell yeah, dude. So we can probably just go like, I don't know. Depth start iterator for our B tree dot. We need to know, I guess maybe we just pull it out of the B tree. This is kind of silly, but it allows us to automatically have this. Which allows us here to just go be like, okay, yo, our B tree, can we please get some of these guys? And I guess that kind of means that serialized node probably wants to serialize into some JSON writer. And I don't want to deal with the types here, so I'm literally just going to write any type here. This kind of goes like this. And we take all the stuff that we just yoinked out of this guy and we move them up a layer. So maybe we go like a serialized tree. We take this and this. And we get our allocator and our tree, which again, I just don't want to think about the types because the types have like compile time data associated with them that I don't want to have to like hard code in here. So fuck it. So we go var node is the root node. While true, because we're gonna have to figure out our exit point at some point, but I don't know how yet. We're gonna go. We need some like depth iterator, right? And hopefully we can find a way for these types to get resolved. So tree with the allocator and the B tree, probably. Okay. Sure. Okay, so now maybe this thing will... Nice. Nice! So what does this guy return first? He returns the start of the world. So we'll call this like depth start is depth iterator next. And then depth end is the next one here. And we say, you know, at the end of this, depth start is equal to depth end. And here we must just have to serialize the node. So each node that exists here. So for 0, for depth start to depth end, this is kind of fucked up, but whatever. Node ID, we're just doing some like node ID bullshit. Because we have like a node ID strong type, and we're just like completely violating that thing right now. But that's fine. That's fine. Who fucking cares? Okay, so here we have to do like B tree get node, get by node ID, and we also have to be careful here if like this guy doesn't check. Okay, we're again just like heavily violating constraints of the API, but fuck it. We're just gonna like inspect this guy and be like, if I is greater than or equal to this thing, yeah. In fact, we'll just do this. We'll just write fix me Totally ignoring node ID APIs, and that's okay. We'll call this block here, and we'll break the other block here. I think it actually might have to be like this, if I remember correctly. Then we just go like btree key storage items I. Okay. This is the node, and then we serialize the node into the JSON writer with the node. Wow. And so all we have to do now is make sure that we start the appropriate arrays. So for each depth level, we go begin an array and end an array. Okay. And then probably we need to do a top level thing as well. We need a top level thing. Okay, oops. Yeah, this guy does need const is totally fine here. 453, he's pissed because he didn't write try here. We don't return somewhere. True, because this guy doesn't need to return anymore. And can we just go to data here and see what we get? Looks like we fucked up. But it does also look like this is the top level node. Then at the second depth level, we have these things. Then the third depth level gets kind of fucked up. Probably because this break outer loop, huh? So I guess it's kind of like this. There's a better way to represent this, but I don't give a shit right now. There we go. Okay, so now we have depth level 0, 1, 2. 2 is empty. And that's chill. That's pretty fucking sick. This series makes me want to make a visualizer for like every project, even when I know very little about graphics. I will say I've never regretted doing it. Defer end array, but the end array can fail, so you can't like try in a defer block. So it's fine. It's just like, ew. There's a better answer for this. There's a better answer, but whatever. We don't care. We're prototyping. That's my excuse for running shit code. So, okay, so for row of data, 0, 1, 2. For cell of row, 0, 1, 2, 3, 4. Yes, okay. For elem of cell. I think that this is correct. So I think that we probably want some extra data here. We probably want the the number of elements per. Yeah, can we forward along the number of elements per row? Do we kind of have that? Kind of. So here, like the fact that this is kind of empty is kind of missing the fact that there needs to be empty elements here. So we should probably say, yeah, we should. We should say some stuff. So this should be a like object field. This should be data, I guess. And then before that, we can do things like elems per node capacity. We'll call this. And then we can go B tree. Oh, it's missing. Fuck. I think This isn't like a runtime retrievable value. But I wonder if you can do this. And then here we could do like type of B tree, node capacity. That might work. No, he doesn't like that. But we can we get a little clever? Can we just do this? And then everyone else is happy? I think so. So we just give him a little underscore in his name and then assign him in the structure so that we can extract the type info back out. So now we have node capacity 4, huge for us. Huge for us. And does that give us everything we need? So here we have, like here we know that at depth 1, we have 5 elements of node capacity. Yeah. Yeah, I think that's right. I think that's right. So I guess we need to, for each row, we advance y by some amount, right? Probably something like this. For each cell, and then we probably reset x, right? Probably reset x at every row. Then we do something. For each cell, I guess at the end we need to like advance to finish cell. So here we can probably calculate this by doing like data num elms. This is data here. And what it was is a node capacity times cell width plus the node capacity minus 1. No, actually, I think that's fine. We just do times cell width plus cell padding. And we just allow some padding at the end. And then here we do draw cell with x and y. That's like a maybe. I'm not like 100% sure that this won't work. Okay, so we suck ass for sure. Why? Because here we need to do x plus equals cell width plus cell padding. That's close. That's close. This feels like I'm watching solve their DSA homework. Yeah, it does kind of feel that way, huh? Okay, so what did we fuck up here though? This is clearly not right. I wonder if it's like +1. Okay, so that's not really helping. Can we immediately break after one iteration of this loop? Okay, so there's a 1, 2. Can we then render the second thing on top? If I equals 2 break. Okay, so there's the 4, 5. And it's the 7, 8, 9, 10 are not correctly rendering in the right spot. Because this has to be x plus here. Much better. Much better. Okay, so now either our canvas has to get bigger or we have to render smaller. But we'll just do this for now. And that looks kind of chill. Right, so we have 1, 2, empty slots, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, blank, blank, 14, 15, 16, 17, blank. Pretty sick. Pretty sick. Okay, so I think that the Y padding, I want the Y increment to be higher. So cell like uh we'll call this cell padding can be like X. Cell padding's fine, and then we just call this like row padding is equal to like 50. So this just gets row padding. Boom. Okay, not bad. And now we probably want to render like a background behind each of the cells um, to make it clear that they exist. So I guess we'll call this render cell and render node. I guess that will be the node of row and cell of node. We need consistent naming here, so we'll start there. Okay, so that's working still. And then let's say render node background here. And I guess we just do it at wherever we are. This is supposed to be node end. So it looks like here we take the X and Y coordinates. And do we use like node end here as well? Surely, right? And then here, I guess we kind of get the height implicitly, maybe? I don't fucking know, man. I don't know. This is render node background. And he's got X start, X end, and this is Y center, I believe. And I actually think that this needs to be minus half cell width, actually, for this to be X start. Okay. So fill style, blue. Fill rectangle, X start from probably Y center. Actually, that was probably fine. Y center minus half cell height. Then 2x end and y center plus half cell height, probably. That's not good. I mean, that's like interesting. Oh, because the x is incremented out before, not after. There we go. And I wonder if this is like this, -1. Yeah, that feels... no, that does not feel better. This is weird here. I don't know what's going on there. Oh, because this is length. I'm a dumbass. This is supposed to be cell height and x end minus x start here, probably. There we go. That looks a little better. That looks a little better. And then it's probably like some sort of offset here or something. Let's make a node padding here. Okay, and then I just want to see. I want to see like any evidence. I want to see like some breaks between these. Like that's kind of annoying. It's kind of annoying that we're not seeing it. So I guess we should pass in, like, can we just calculate the node width here? It's like the data dot node capacity times cell width plus data dot node capacity minus 1 times cell padding. Okay, I'm pretty sure that's it. Then here we should just be able to do this. Okay. Yeah, that seems kind of... Maybe, like, it will behave a little bit more reasonably. No, he's pissed? Why? That's actually kind of really confusing. X plus node width plus node padding. I mean, this just must not be working correctly. Nan. Okay. Because I spelled node capacity wrong here. Fucking garbage ass fucking language, dude. So why is it getting like extra blue on the side here? That's kind of what I'm confused about. That's what I'm confused about. Because here the node width, node capacity is 4. It should be, right? Yeah, 4. So we have 4 node capacity times the cell width. That's all of the gray blocks, right? Chill. Plus the padding. So what if we just take out this plus the padding? That makes sense. Whoa. Node end here is only used to increment x. Okay. If we increase the node padding by a lot... Oh, there we go. We're starting to see some gap now. So now my problem is that somehow the width is getting calculated just like totally fucking wrong. Which is confusing to me. Node capacity times cell width. Sure. Plus data.node capacity minus 1 times cell padding. Like, am I fucking mental? It almost feels like... oh, yeah, wait, yeah, plus node padding. Render a cell. He gets rendered at some location at the center. Oh, because these things are centered, then that means the node background start is at the wrong spot. There we go. That makes way more sense. There we go. Okay, now can we just like expand everything by like minus x width times 1.1? Can we do like with border? Right, then we go like x start minus... Jesus. We need to calculate the x center, I guess. Something like this. Then we do x center minus x with border. over 2. And this is like plus x with border over 2. Nope. Oh, because this is x with border here. I'm a dumbass. Still not right. Right. There we go. 1.1. Boom. He's a little padded on the x. Then we need to pad him on the y as well. So we just say y with border is cell height times 1.1. This is y center minus y with border over 2. Y with border. All right. We go E. We can definitely go bigger on Y. There. There we go. Now that looks, you know, pretty decent. The colors are shit, right? But we can fix that. All right. Even just doing that makes it a lot better. A lot better. We could change the blue, but it's giving Spider-Man birthday party. Hell yeah, dude. Okay. Now, I guess the last piece here is that we need to make sure that we can tell who is parenting who, right? So once we get into a third row, which I actually think we can't do right now because our fucking thing is broken, it would be nice to be able to see like probably gaps between each of these guys, right? I assume that we're gonna want something that's like, we have, this guy has like 3 children, and then we want to show like the next guy with his 3 children, kind of like here, right? Which means that the distance between nodes is like relative to how far they are from the bottom row or something. Something like that. Something like that. Yeah. And then, of course, each guy has 5 children, so in reality, this is going to get out of hand really fast. Is there like a better way to show this? Where it doesn't like explode horizontally so fast? I mean, you could say you could turn it sideways and explode vertically, but is there a way to like you could do like a tree view? I wonder if that looks better. Right, you have the root, and then like child 1, who has his child 1, 2, 3, then child 2, 1, 2, 3. Does that look better? I mean, it feels like more compact at the very least. But still maybe not great. Sure. And then how, if we wanted to collect things this way, how would we show it? We would like, we would have to build more of a tree structure in the JSON. Okay, how about this? How about this? I don't have a good answer right now, and I kind of want to get onto the next part of this. So I'm going to leave this kind of looking the way it does right now, which isn't great, right? But I would rather move on to like the modification visualization, because I think that that's where the actual value of this thing comes in. We kind of want to see how this thing changes over time. And so it would be nice to just be able to write step, 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 step here. So let's do that. Let's do that. we'll just leave it the way it looks for now, and we can always improve later. Okay, so how the fuck do we do that? I guess we're gonna have like some B tree, right? And I guess we are going to have an insert sequence. Which has all of the things that we've done here. Boom. This is how you write code, right? And then here we just go, what? We go like record a macro, delete to the parenthesis, jump to the other parenthesis, put a comma, go to the next line. Okay. Uh-huh. Okay. Cool. So then we ditch all of this stuff. And I think what we do is we say we support like a next function. Step maybe. And as we step, we literally just do B tree insert the next thing. Insert IDX from insert sequence. And we only do this if insert IDX is less than insert sequence len. And then we go success. We did it. And then in our thing, we go button step. And this is an ID of step. And can we actually, how the fuck do button, do I need to use JavaScript for this? I always use JavaScript for this, but like, can I make a button get in HTML without JS question mark? Okay, so I need to use a form. Yeah, that's kind of crazy, but yeah, okay. So we use JavaScript. It's fine. Okay. Type HTML canvas HTML button element. Nice. Const button step button is document get element by ID step boom boom step button on click equals something that does something. And I guess it's literally just like fetch step. And then after he does that, he updates the data. So that means that like all of this stuff needs to go into like a render function. Right? Like all of this. And he needs his like context here as well, right? Is there anything else he needs? Maybe not. I think we're probably chilling. So I guess all of this kind of goes in there too. This like fill the thing with white, which means that the canvas, he needs, I think it's CTX param HTML renderer canvas rendering context 2D. So do I have CTX on here? Yeah, now I do. So there's like CTX canvas. Yeah, here we go. Okay, so he's chilling. So we should be able to call like render now with like CTX and data. And then here we should be able to go like can I make this async? Oh, hell yeah. Let me just do this again. Boom. Fuck it. Main Zig, he's mad that 491, we never changed the insert index. He's mad at insert. Whoa. What? What the fuck? Oh, is it because insert sequence is used as a sequence of comp time ints, so we need to say this is a slice of I32s? I think it is. That's crazy. Crazy. Alright. Boom. Step, 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 step. Wait, that's so fucking sick, dude. That's actually so cool. Fuck, that's awesome. We could try to get a little bit more granular there, but that's pretty sick as is. So I don't like, we need a reset button here as well. So first of all, this needs to not say step like this. So we need reset. Which means that our server needs to support reset in some way. Reset, bing, bang, boom. If we get a reset, we go. We succeeded. But before that, we go insert index equals 0 and b. I guess we just reassign the b tree. How did we do this before? B tree deinit, boom, and then we say b tree is equal to b tree this shit. We'll call this like test b tree is a b tree of 4 I32. This gets test b tree here, and then now we can use test b tree down here as well. Boom. Boom. Presumably this can fail, yeah. All right. Fuck. Okay. Step, 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 step. We didn't hook up the reset button. I guess I didn't have to kill the server for that, but it's okay. Reset button does an on click that kind of follows the same pattern here, and he just calls reset though. Boom. All right, that's like a maybe. Boom, 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 boom. That's not good. We do need to use the right button. Step, 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 reset, step, 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 reset, 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 bump, 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 bump. That's so hype, dude. That's so cool. Okay, so now we can see like, okay, we put the number 5 in. We put the number 7 in. We put the number 3 in. He gets sorted to the left here. We put a 9 in. We put in the 6. And boom, these guys get split out. Okay, so what would be nice here though is like, I would love if like it wasn't so immediate. You know what I mean? Like it would be sick to see like when I hit step, I would like to see like an insertion like element show up here, 7, and then like show where it goes, and then put the 3 here, and then like move the 3 in. I would like, and then what I would love to see is here, like what happens is we have this like 3, 5, 7, 9, right? And we come in with the number 6, right? We stage a 6. And so what happens there is like we create a new node, put 3 and 5. We create a new node over here, put 7, 9. Then we delete this node and put a 6. Right? And I would love to see those in like individual stages because that would actually be helpful in helping us understand when things go like sideways. Because things do go sideways, right? But instead we just see it all at once. Which means that like the insertion needs to have like pausable checkpoints, right? Like right now, we have one call. We have this one call. It's insert, right? And in insert, we go, okay, let's find where it should go. Then let's insert at this node, and we try to append. If the append fails, then we split the node. And in split node, we go, okay, let's like actually do the split. We do like the first half of the split and the second half of the split. Maybe we could kind of do all of that at once. Then we recurse and we like insert the element into our parent. So I guess what I really want is I want like this insert at node parent element to be like a second step in some form of like iterator or something, right? I want to be like, I'm imagining there's like something that's like B tree inserter. And I'm kind of imagining that like, maybe this will live here for now. It's easier to do it here. Right, so I'm kind of imagining that we have like a value and a node ID where we are like inserting this thing, right? And I'm kind of imagining that like I don't really know. We go like step in some way. Surely he has to hold like B tree is self or something as well. He needs like the actual data. And I'm imagining that I guess split node here comes in steps, which means that insert comes in steps. So we could even like, we could say first, okay, let's like kind of like write down the sequence that we see here. Find target leaf node, that's this part, right? Then we insert, we try append to node, to leaf node. If that does not fit, I guess it's like, if node is full, is not full, append to leaf node, return. Otherwise, I guess it's like finish. Otherwise, we split node. So in split node, we say if root node split root, else finish. Otherwise, I guess maybe actually we'll look at the root split first, since that's kind of the case that we're in first. Okay, so it's like create empty child 1, create empty child 2, create empty children, I guess. Copy into child 1, copy into child 2, and then insert final element into root. So that's like kind of like the sequence here. And I just kind of feel like, where would I want to see, where would I want to see things happen? I guess what would be nice is if we still had the 3579 up at the top and the 3579 below. I think that would be like visually clear that things are working. Or we could just make this empty at the top and move the 3579 down here and show like the staging element here. Yeah, I think that would work. Okay, so maybe before we get too crazy, we should probably commit so that we don't get like too fucking far gone. So let's just run this one more time just to make sure. Yeah, okay. So git add-u, git commit-m, checkpoint with viz. Okay. So I guess we could just slowly build back up the current insert with this inserter API. And show the current state and the inserter as we go. Seems reasonable to me. Seems reasonable to me. This is kind of like a super like unconventional way of writing this code, but I do think that it will allow us to visualize as we go, which would be kind of cool. Okay, so I guess off rip here, we kind of know if we have a target node that is part of this inserter, I guess that kind of means this goes like this. So if I guess the inserter needs some sort of state, right? And we'll have finished for sure. What else do we have? Find target leaf node. If node is not full, append to leaf node. So I guess we'll just call it append to the target. So here we have state is equal to finished, right? Which means that like val is equal to val. I guess like the rest is undefined in this case because we don't actually care. Which means that maybe this will just return no. That's kind of easier, I think. Okay. Otherwise, we just do this. Here's our target, here's our value, and here's our B tree. Okay. So now we are going to have some sort of inserter. Which has like test btree dot inserter optional is null. Okay. So I guess here we say if there is an inserter, we I step, right? Otherwise, we say inserter is equal to btree inserter. And here we have to flag completion in some way. So here we say if this returns false, yeah, I think we usually do like while step. So if this returns false, inserter equals null. Okay. Otherwise, we make an inserter. Okay, cool. Now, I guess we need to make the inserter with insert sequence insert index and insert index plus equals 1. Okay. So he's going to be mad because the inserter just does jack shit. So what now? What now? I guess we'll just do the simple. We can do step 1 right now. We can say if btree get node by ID target. So this is our node. Okay. If node.num_elements, I guess here we need to check our state. If we're finished, return false. If we're in the append state, we do this. So if we're appending, we check the current node. If this thing is full, then we have a fucking problemo. So I guess we return false here. I guess, fix me do split. But if not, it's simple. So we just append the node. And we move into the finished state. Sure. Okay, so this should allow us to fill in the root node with the current code, I think. This needs a star here to let it be mutable. What is this returning? If it succeeded? Oh. We should know it succeeds at this point. What's he pissed about now? Okay. Missing struct field state. So here he is append by default. All right, so now we should go step. I was So this is having to be clicked too many times for sure now. 1, 2, 3, nothing's happening, right? So like what the fuck is going on there? First click creates the inserter. Second click runs the first step, which should append the node. So the third click being required is the thing that's surprising to me. That's a thing that's not expected. So what the fuck is going on there? Interesting. We could maybe log here what happened. Maybe we could even just log the root node. Get root node elements from 0. I guess we need like node is this. We want to log from the node elements from 0 to the number of elements. That's kind of what I'm imagining here. And can we just do this literally every fucking time anything happens? I guess maybe only when step happens. Okay. So we refresh, we step. Root node is empty, that makes sense. Step, root node has a 5. Okay, so clicking it twice is enough. I see. It's the 3 was confusing me. The 3 was because we also have to step to finish. So I guess our step function here, we might just not want to have a finished state. Or maybe we return false here, but leave it in the finished state to flag for later. if somebody calls it again when they shouldn't. Okay, 1, 2, 1, 2, 1, 2. That's a better cycle. That's a better cycle. Okay. Now I want to show the work in the like item that is about to be inserted. I want to put that somewhere, right? So that means that when we retrieve the data from the server, this guy, here we want to pass the inserter here as well, I think. And here we'll just say like insert like to insert is going to be like if inserter, we write ival, else we write null. Okay, so now we should be able to go back to wherever the fuck our... Did I fucking close it? What kind of dumbass am I? Here we go. Okay, so we step once, and then we go to data, and we should see to insert 5. Good, that's huge for us. We hit step, he writes a 5. We refresh this, to insert null. Huge! So now we can like show that somewhere. We can show that in like a staging area. So we can just be like, if data to insert is not equal to null, we render a cell, I guess, at literally just like 25, 50. He's mad because I need to run the code. Close. Let's go down a little bit. $50 minus cell height minus cell padding. Maybe that's the play. What the fuck? Oh, wait. We can actually do it at 50. Because we increment y immediately. There we go. Okay, so 5, 5, 7, 7, 3, 3, 9, 9, 6. Okay, now the 6 gets broken because he doesn't actually know how to insert in this like new API. But that first row looking kind of slick. Look at that. That's kind of fun. That's kind of sick. Okay. Okay. So now we just have to re-implement the rest. That's just make the whole thing. We just have to do the making of the thing that we want to make. Shut up. Okay. So we need to implement this split. Probably split root is the next thing to implement here. So if we are in the append state, I wonder if it makes sense to like, maybe it makes sense to do this in a loop here. And kind of like flag ourselves with like breakpoints. You know what I mean? Like areas that we were like, okay, we've done an action. Right, so kind of all of these cases where we say state equals finished. We allow the return to go through the finished state. That allows us to try to append something and then move into a split state after that, right? So here we go like, okay. We try to append, we do like, if we append the node successfully, we're like donezo. Boom. Otherwise, though, we need to go into split. Yeah. And then we have a split state. And we're splitting the target. So we have split state. If we are splitting this node, we just run split node. And I think what I want to do is I want to kind of I'm thinking. It's easiest if we do this split root thing first, maybe. So the split root is really straightforward. He literally just takes like half the elements and he puts them in the first child, put the other half the elements, puts them in the second child, and puts the center element in himself. So I think what I want to do is I want to take the existing split root and kind of do like split root no insert. Which is kind of weird. Maybe this does just deserve to be its own step. Maybe it does. Like we could try to show 3579 with. Oh, it is worth doing. It is worth doing. Never mind. So I guess we could just kind of copy paste this function into the inserter. Like this. And everywhere we use self, it's self.btree. Okay, and then we just don't do the part here. So we split the root. Here we say if node, if self target is equal to root node, we split the root with this value, with, I guess the value is kind of already known. Okay. Then after we split the root, we go back into the append state. Yeah. That seems kind of reasonable. The fuck? Oh, this thing isn't allowed to fail right now, so we'll just fix that. You are now allowed to fail, sir. Okay, so now we come up here. We go steps. 3, 9, 6. The root split is not happening, which is not good. Why not? Oh, here we probably want to return. We're like, hey, we've done a, maybe here we want to return. And then probably else we want to do self state is finished. Yeah, so here's like, we did a thing. Take a break. What was he pissed about? 265? What the fuck are you complaining about? Expected type this, found void. Oh, I see. Step. Oh, that's so sick. So now we see the 3 and the 5 ended up down here, right? We're inserting a 9. Boom. 7, 9 here, 3, 5 here. Oh, this. There's supposed to be a 6 show up here? So that's a problem. We need to set this split root needs to return he needs to set like self. He needs to return the like node ID that is the new target. Or val, I think. Which means that this needs to return a t. And this needs to return node splitter dot parent element. Here we go. Boom. Step, 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 step. Boom. So now the 6 stays up here. And then the next step should be that the 6 gets inserted into here. So we actually have to clear the root as well. So I guess it's kind of like this. Boom, 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 boom. Oh, that's so sick! Okay, so this is a bug though, because I think that things are going into the root now when they're not supposed to. So the 6 goes here. This 11, I think, is supposed to go here. And he's not. So why? I think it's because when we set the data of these, I think we're supposed to set that the root is no longer a leaf node. I think that kind of fucks shit up. Okay, boom. Step, 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 step. 6, boom. 11, bottom right. 12, bottom right. 13. Now we need to handle splitting of these nodes down below. So I guess this else we should crash. I guess that's kind of the case we should be in. Boom, 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 boom. So we're hoping to crash here, which we do. Really good. Really good. Okay. So now we just need to copy the existing function for split node. Boom. This guy. And just kind of break him up a little bit. So here we don't need to do the root check anymore. The value and the node ID are shown, are part of our self inserter. We have the target, we have the value. Okay, so anywhere we use like node ID, this must be self target. Boom, up. So that's only a couple places. Then all we want to do is at the end here, instead of going insert at node, we want to return like next action probably. So I would love if this could be const actually on both of these, so that I don't have to worry about like calling this function having internal state mutate. Then here we just say like next node is a struct. He's got like the new target and the new val. And that becomes next node here. Then here all we do is like return the next thing that we want to do, which is like we have some what do we call it? We called it, we can just do this, target val. Target is parent ID. So target ID val is equal to node splitter, the thing that we're supposed to put in our parent. Hell yeah. So then here we just say split node. And we go self val is next node val, and self target is equal to next node target, and we switch our state to append. That's pretty fucking sick. Everywhere that's using self here needs to be self.btree now, because this is a wrapper around the btree. Step. Okay, so we get this stuff in. 6, 11, 12. Oh, that's so sick. And then it would be also nice to return here, so that we can even see which node got kicked out. Right, so we come back here, zoom out a little bit, refresh. We go 5, 7, 3, 9, 6. 6 is still up here. 6 gets put into the parent. 11, 12, 13. 13 is going to go in here. Boom, the 13 shows up here. He gets swapped out with the 11, and then the 11 goes into the root. That's so cool. It's actually so sick. It's like, I expected this to be kind of harder. Where's the 2 going to go? The 2 is going to go here. Boom. 4. So the 4 is going to try to go here. Then the 3 is going to get kicked out. The 4, I think that's what we expect. Yeah, so the 3 gets kicked out. The 2 goes in here. These guys get kind of moved over. And now the 3 tries to get inserted into the root. Boom. That's actually, like, incredibly sick. Incredibly sick. I think that's a success. That is a success. Cool. So, pretty sick. Thanks for watching, guys. I think we'll call it there. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is almost 4 o'clock Pacific time, so if you're watching live now, you should expect to see us live between 3.5 hours ago and now. If you're watching on Twitch, there's a YouTube link in the Twitch description. Projects are organized into playlists. You can keep up on what we're working on. I think that this is ending up in the Mizik playlist because, I don't know, this is like only tangentially related to our code map stuff. Code for this, I didn't think would go up on GitHub. It probably will. I'll probably make a repo for this at some point. GitHub link in the Twitch description. Think that's all I want to say. YouTube, peace out. Twitch, let's find someone to raid.